Okay, taking a look at capacitors today and seeing how they work, we can see that there's many different kinds of capacitors. There's ceramic and mica disc capacitors, there's mylar capacitors, and there's electrolytic capacitors. Then we have air variable capacitors, which have air dielectric, which is the insulator between the plates. Then we have other types of variable capacitors that have different types of dielectrics, such as this one. The capacitors that we'll be using in this circuit will be the one I just showed you and an electrolytic. Now, speaking of a dielectric, the dielectric is actually the insulator between plates of conductor, which make up the capacitor. Different dielectrics have different tolerances for voltage. So you should know about the breakdown voltage of a capacitor. If you exceed that, you will damage the dielectric, which essentially shorts out the capacitor and destroys it. The air variable capacitors, they use air, so if you arc between the two conductors, you're not damaging any dielectric because it's air. There's no material in there. So capacitors are nothing more than a conductor connected to a little pin that comes out of the bottom of the capacitor. And then you have an insulator and a conductor and an insulator and a conductor out to and however far they need to make it go to get the value of the capacitor. Their capacitance is measured in farads or microfarads or picofarads. And that's basically the way all capacitors work. Electrolytic capacitors, they have a little extra going on in them. They have an aluminum plate and then an electrolytic plate and then a dioxide or an oxide dielectric, a plastic film, and then the next aluminum plate, and then the wire leads.
Capacitors store energy because one side of the capacitor holds an abundance of electrons, while the other side holds an absence of electrons, or an abundance of holes for the electrons to occupy. Because of the resistance of the dielectric, keeping electrons from jumping over to the other plate, lines of force between them are set up, producing a sort of resistance known as reactance or capacitive react. Capacitors store energy somewhat similar to a battery cell that stores energy chemically, while capacitors store energy in an electric field. Capacitors charge and discharge over a certain time depending on the capacitance of the capacitor and the frequency of the current being applied to the capacitor. Now there are three uses for capacitors. Timing or delay, which we just explained above. Because the capacitor takes time to charge and discharge, it can be used to time something or set up a delay for something to happen in the circuit. The higher the capacitance or Farad rating, the longer the charging and discharging cycle takes. Therefore, that is how it can be used to time or delay a circuit function. Now, capacitors can be used as what is called either a coupling capacitor, where the capacitor is used to pass AC and block DC. The higher the capacitance, the lower the frequency it will pass. Then you can have a decoupling capacitor, which is used to smooth out a fluctuating DC current or ripple.
And we want to look at this, we're going to see how capacitors store energy. Our circuit looks like this. That's how our circuit is wired. Now we're going to take this capacitor out, and you'll see in the little diode, we're going to take our battery and put them in here. You see it light up, you undo it, and it goes out instantly. Now, if we put in a capacitor in parallel with the
light source, whether it's a light bulb or a diode. And notice here, it had that black band, the black band going to the negative side on electrolytic capacitors. So we got to put it in the right wire and the correct wire and poke him down. Now, and then we have our resistor here, and we'll talk about that in a minute. Now, if I put this in here and let it off, you saw that it didn't go out right away. It slowly faded out. And we're going to do it again. We're going to zoom up on it. And I'm also going to darken the room dimmest that it doesn't go off. You can see that it's still glowing. It's still a little bit. So it doesn't go off. And again, we'll pull the capacitor out and do it one more time with the capacitor with it zoomed up, and you'll see it goes out right away. There's no fading. That's because that capacitor stored energy in an order. If you go too high with the resistance, there won't be enough, there may not be enough current to light up the diode. If you used a light bulb, you could use a broader range of voltages. But if too much resistance for this to light up the diode, it won't light up anyway. So on our circuit, we want to solder our capacitor, our 10 microfarad capacitor. Here's our 10 microfarad capacitor. He had little legs on him I showed you before. I think I took those off in the meantime. It helps to have those if you have short legs on him. Okay, we want this right before our resistor, because remember, back when we made this circuit, this resistor was only to control the brightness of that diode. So we do not want to put our capacitor here, because our capacitor is going to go here. The rest of the circuit's going to go off in this direction. We want our positive side on that resistor. I hope you enjoyed this video and found it useful. Please like and subscribe, and check out other videos in this series and on this channel. Thank you for watching.